24. And we want to do one of these guys. All right. So Maya, do you have one of these, part A, B, C, D in particular that you're interested in? Or does it not really matter?
B.
Okay. So it says correct to the 0.1 second. So this would be the digit that we would have been rounding. So if I'm rounding up to 1.7, the smallest value it could have been is 2.65, right? And if I round down to 2.7, the biggest value it could be is just under 2.75. And then we're done. Yep, so it tells you the form that they want it written in up in the problem. So does that feel okay?
Yeah.
Yeah, no problem. Anybody else? What we've done so far has been pretty straightforward, I hope. Yeah. Good. Okay. On to the next set of stuff. So in section 3, we're going to be looking at scientific notation, i.e. numbers in the form of like a times 10 to the k. So the idea is that this number a needs to be between 0 and 10, or I should say between 1 and 10. It should be a, ones place, decimal, and then some decimals. So if we have a number like 5,120,000, we're looking at moving the decimal place from from right here, 1, 2, 3, 4, 5, 6 places. So that means we multiply by 10 6 times. And that's how we get the 5.12 times 10 to the 6th. We've all done scientific notation before, right? In our at least some point of math education and or science class, I'm sure we've done this. I don't want to beleaguer this, but I just want to make sure that if it's been a minute that we just talk through it again. If it's a small number, I'm going to be moving my decimal point to the right so that it's, again, a ones number, or that the first decimal is in the ones place. So I'd move it 1, 2, 3 places to there. So 6.84, and because I'm moving left, it's going to be like dividing by 10 3 times, which is the same thing as a negative exponent. So if we're moving the decimal point left, you get a positive exponent. If you're moving the decimal point right, you get a negative exponent. What's the other easy way to do this if you're not sure? Point out to you that if you take your calculator and you put it into scientific notation mode, you can type in a number like 5,120,000 and press enter, and it just does it for you. Now, I don't think that you really need your calculator to put things in scientific notation, but like in a test setting, if you're having a doubt, it's nice to remember that your calculator will do that for you. Turn that back off and continue along the way. Okay, we did this. And then if I want to go backwards, oh good Lord, I mean, again, you could, in normal mode, you could type this in your calculator and press enter, or you can just think about, okay, I'm moving the decimals 6 places.
I'll take it.
Check it out. I see one.
Yeah.
Okay,
Do you really need it?
Thank you.
no problem. All right. Or again, if you're changing your decimal for a small number, again, you're just moving the decimal point to the left like 3 places. It's the same idea. Or you could just type in your calculator and press enter, and it'll give you the, the standard form number. No biggie here, right? Guess what? That was section 3.
Yay.
Can you put things
Wow.
in and out of scientific notation? Woo! I know. Your brain's burnt. Well,
Yeah.
thankfully, there's not a ton in this section either. More than the previous one.
Are we only doing 2 today?
There's only 2 more sections in chapter 1.
Oh no. We're gonna have a test?
Yeah.
Oh my god. Wow.
Actually, we got to do a quiz and then the test. Yeah. We'll talk about what to expect on both cases. Look, no. Listen. How easy has this stuff been? Like, really pretty easy, right? Like, you should be like, thank you. Yes, let's have lots of quiz and tests on this. Like, pad my grade up before anything difficult runs up. Like, I can sure as heck round some numbers and put things in and out of scientific notation and like identify if something's an integer or not. Like, yeah, buddy, let's do this. I'm just challenging you to look on the positive, right? All right. Section 4 is on exponents and logarithms. So our basic properties of exponents. We did these already once earlier, remember? So I'm just stating them again. I'm not going to kind of go through these again and kind of what they mean unless there's specific questions here. Will you have to recite a property of exponents? No. Should you be able to use them in context? Yes.
Are we gonna have this?
I will check and tell you when we start going through what the test and quiz will look like. I will for sure tell you what's going to be given to you on your equation sheet and what won't. But I have to look because I honestly don't remember anymore. Is everybody happy here? Again, we did this earlier, so I don't want to do it again, just like one class period later. Our basic properties of logarithms. This we will go through slowly because we haven't done this yet already. So again, remember our definition of a logarithm says that the equation b to the y equal to x is equivalent to the equation log base b of x is equal to y, where the answer to this logarithm is basically what exponent of b gives us x. So a logarithm, the output is telling you an exponent, right? So given that b is b and x are both positive, and then b is not 1. So that's just our definitional for logarithms. You can't take the log of a negative number, so the x value can't be negative or 0. And the base of an exponential and the base of a logarithm kind of have the same rules, where that base can't be negative, that base has to be positive and not equal to 1. So again, you have the same rules for logarithms. So you have your basic one, like log base b of 1 is always 0. That's equivalent to like a to the 0 is equal to 1, right? We've seen that property before. Log base b of b is equal to 1. Well, that's just saying that like b to the first is equal to b. And then you have your inverse property. So log base b of b to the y is equal to y, where the log base b cancels the exponent base b and leaves you with just the exponent. Or the reverse is true. If I take b and I raise it to the log base b power of x, again, exponent base b cancels with log base b, and all you're left with is the argument of the logarithm. Is everybody okay with that idea? These are just like the basic cancel out properties for logarithms. Okay. There are two special logarithms that get special names depending on their base. The first one is the common logarithm. So the common logarithm is where the base is 10. We just write that as log, and we don't typically write a subscript down there. You could write 10 down there if you wanted to. It's not wrong to do that, but it's unnecessary. It's like putting a 1 in front of an x. Like, we know the 1 is there, we don't write it. The same idea here. If you just write log with no subscript, we know there's a 10 there, even if we didn't write it. And then the other is the natural logarithm. The natural logarithm is a log with base e. The notation we use for that is ln. So if you see an ln, that's not 1n or in, that's ln, and that just means log base e. And again, this should all be review, right? We kind of remember this from previous courses. I think you should do this in Algebra 2 as well as pre-calculus. So it should be relatively fresh. So on your graphing calculator, the log and natural log buttons are here on the left-hand side. Probably already knew that. All right, let's do a couple of examples. If I want to do log of 100, now, obviously you could type that in your calculator and press enter, but let's kind of use this as an opportunity to review these properties of logarithms and do this without a calculator. So the base on the logarithm in this problem is 10. So I want to rewrite 100 as a power of the number 10. 100 is, as a power of 10, 10 squared, right? Oh, we did it. I did it this way. That's fine. We can do it this way. All right. So we'll use the properties of logarithm, or we'll use this definition of logarithms to do this, I suppose. So here I see that the b is 10, the x is 100, and the y is like my variable. So I call that just x. So I use my properties of logarithms to rearrange this. So I have 10 to the x equals 100. Well, I know that 100 is 10 squared, so x has to be 2. Or you could think about this as just like 10 squared, and then log base 10 cancels exponent base 10, and you're left with just the 2. It's correct to think about it that way as well. Or in all reality, in a course like this, you can type in your calculator and press enter. Always will be allowed a calculator.
What do we type in?
Log of 100. If it says evaluate log of 100, you just type it in, press enter, man. You know, no biggie. Sounds like I can handle that. All right. If we have log of the 5th root of 10, so if we approach this the same way we did before, we'll write this as log of the 5th root of 10 is equal to x to make a logarithmic equation. I recognize that log is log base 10. And now I'm going to do my rearrangement. So I'm going to get my b is 10, my x is 5th root of 10, and my y is x. So I have 10 to the x is equal to the 5th root of 10. And now I'm going to rewrite the 5th root of 10 as a power of 10. How do I do that? 10 to the 1/5, we remember that radicals are the same as a fractional exponent. And so from there I can see clearly that x is 1/5. So log of the 5th root of 10 is 1/5. Again, you could type that in your calculator and press enter, right? You could also do it that way. not wrong. This is an opportunity for me to kind of review logarithms a little bit, rather than just like, how do we get the right answer as quickly as possible? Let's review some of these properties to make sure that it still sticks. This is often a difficult topic for Algebra 2 and pre-calculus students, is the logarithms piece. So seeing it for a third time is not a bad thing. All right, next one we have log of 1 over 1,000. So again, we'll start the same way, turn it into a logarithmic equation, recognize that log is base 10. Use our definition of logarithms to rewrite this as an exponential equation. 10 to the x equals 1 over 1,000. I want to rewrite now 1 over 1,000 as a base 10 number. I recognize 1,000 is 10 cubed. So 1 over 10 cubed is the same thing as 10 to the negative third. So we'll do that. And then from there I can see that x is obviously negative 3. Any questions on what we've done so far? Still okay? Looks familiar? We do this third time doing this, so it should be okay. Let's go to the next one. Oh, forgot to put those on. Anyways, so we have 10 to the log of 6. So again, we'll set that up as an exponential equation this time. So here we see that the b is 10, the y is log base or log of 6, and then the x is just x. So rearrange this as a logarithmic equation. So we have log base 10 of x is equal to log of 6. Well, I know that log of 6 is just log base 10. And from this equation, hopefully it's pretty obvious that x has to be 6, right? So we're done. Or you could think about it as, again, like log or exponent base 10 cancels log base 10, and we're left with just the 6. That's fine as well. Equivalent to what you're doing. All right. Okay. What if we have log of x is equal to 4? So again, we'll start the same way. Recognize that log is log base 10. So I see the b is 10, the x is x, and the y is 4. Let's make that into an exponential equation. So 10 to the 4th is equal to x. Well, I just 10,000, and I'm done. Easy peasy.
This math class, we always going to have these.
10 or e. Yeah, so it'll be logs or natural logs. Let's see what happens if you don't. So really the same problem, right? So again, we have our logarithmic equation. Our b is 2, x is x, and y is 5. So I just have 2 to the 5th is equal to x. 2 to the 5th is 32. I appreciate you checking. Oh, yep, that's 6. All right. Some other properties of logarithms we haven't yet mentioned. We have the change of base formula. Now, when I was a student, this was super important to me because I did not have a calculator with a logarithm button on my calculator. You know how we did these logarithm problems? So you had a table of values in the back of your textbook that you had to look up the value of a logarithm, like base 10 on. And so if I wanted to do log base 2, I had to use the change of base formula every single time. I couldn't just type it in my calculator. I'd like to remind you guys that on your graphing calculators, if you press the math button and you scroll all the way down, you have the option to use the log base command. Oh, that's embarrassing.
That's not legal.
Where you can input any base for your logarithm. So if you wanted to do log base 2 of 5 or something like that, you can just type it in and press enter and it'll spit it out for you. You don't need to use a change of base formula, but I'm mentioning it here. So if I wanted to do log base 2 of 5, I can pick any base logarithm. The base you'd want to pick is either 10 or e, doesn't matter. So I could do this as log base 10 of 5 divided by log base 10 of 2, and I'll get that same answer. Or I could do natural log of 5 divided by natural log of 2, and I'll get that same answer. It doesn't matter which route you want to go. They're all going to give you the same thing. Just pointing it out to you. Why the change of base formula probably means a whole lot less to you guys than it did to me. Okay. Blah, 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 blah. Yeah, log base command. Okay. So we just did an example using the change of base formula by hand. I'm not going to walk through this. Is everybody okay? Blah, 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 blah. And is that the end? Yeah, that's the end. Okay. Great. So if you guys look, the next homework set for sections 3 and 4 is on My Notre Dame. I'll get that in as an assignment here before we leave today. This sections 3 and 4 will be part of not this Sunday's homework check, but the following Sunday's homework check, because I want you to have a chance, if either you see something you have questions on, to have an opportunity to come back and talk to me about it. Everybody feel okay there? Sounds pretty reasonable, I hope. All right. That looks good there. All right. Let's talk about the this test and quiz formats. Let me just grab my copy so I don't speak out of turn. All right. So the quiz, you'll need to if I give you a number, identify what number sets it belongs to. So for example, if I give you the number 8, what sets does that belong to? Natural numbers, integers, rational numbers, real numbers. Okay, natural numbers. Anything else? Integers also. Anything else? Real numbers. Anything else? It's also a rational number, right? Because you can write it as 8 over 1 or 16 over 2 or something, right? So it's all of them. That's what you'll be doing. Okay, like one question will be like that. I'll give you a couple of numbers. There'll be like A, B, C, or D parts kind of thing to it, but it just can you recognize like what stuff? Where does this belong? Cool. No big deal. Okay.
Oh, that's my nostril.
Okay, you should be able to, you'll be asked to plug some numbers into a formula, round to a given, round as directed, or format your answer in scientific notation. Ooh. So you should be able to, you'll be asked to do a percent error calculation. You'll be given the formula. So just like, can you plug the stuff into the right spots? Celsius? I don't know. How do you spell Celsius? I'm a terrible speller. Nobody has any? Help me out. That's apparently not close enough for it to offer a suggestion. It's. I just needed to get closer for it to offer a suggestion. Okay. CELSIUS. Oh. Oh. Yes? Okay. Oh, it wasn't capitalized is what it was. That's just. Okay, you'll have to convert from Celsius to Fahrenheit to Kelvins, but you'll be given a, given the formulas there. You'll be asked to find the bounds for a rounded number. You know what I mean there? Like the homework problem that Maya asked about. Kind of like that. So you should be able to do basic operations on numbers in scientific notation. So add, subtract, multiply, divide, exponent. I will tell you here in a moment. So it's hard because there's like a lot of these have parts, So it's like it's 9 questions, but there's some of these have like a bunch of parts, so it feels way more than 9, but okay, you should be able to solve an exponential equation.
I'm just kidding.
Okay. And the last two questions, you should be able to solve exponential equations and or rewrite an exponential equation as a logarithmic equation and then solve it. So hopefully that feels, oh my God, I'm so dumb. No, I made a tremendously silly mistake. Because what I just did is I just typed the test format again, I think. Yeah. Yeah, that's pretty silly, isn't it? Yeah, I sure did. That. And I'll try this one more time here, folks. All right. Of course. Okay, so still that first problem, still kind of the same. Should have to calculate percent error, even though I give you the formula. Should just copy and paste these stupid things in here. I need to change that. Should have to do temperature conversions. Some basic unit conversion. And then what? Yeah. Just make sure you don't fill your water with your bathroom. Gross, Mr. Kulik. She'll have to simplify exponential expressions. So you'll use your exponent rules to do that. Solve exponential equation. I don't know why bother. This is like the same stuff. You have to round number based on round a number based on the instruction. So you might have the same number that I ask you to round like a couple of different ways. you know, to the 10 spot, to 3 sig figs, to the 100 spot, you know, like whatever. And then you'll give the bounds for a rounded number. Okay. That's the gist of it. It's like the same stuff, right? I have one question for you. We'll plan on the quiz for Tuesday. I want to hear your opinion on the following. Would you rather do the test on Thursday or start the next chapter and take the test the following Monday? Well, I guess it won't be Monday because it'll be Tuesday because it's the Labor Day weekend. You think on that. You don't have to tell me now. We can do it after you've taken the quiz. Whether you want to do the quiz and test in back-to-back days or do you want a chance to get the quiz back, you know, we'll talk again on the quiz day. I just want to put that out there as to like what you guys feel like is going to be best for you. Maybe once it gets a little bit closer and your Labor Day plans come into focus, you may change your mind on whether you want to push something till after Labor Day or not. You know, people have travel plans. I don't know. I'm not in a gigantic hurry to get any of that, you know, that we have to just go bulldozing through stuff right now. That's okay. But you know, I figured I'd give you guys the choice because it's the same amount of time covering stuff for me. It just, you guys might really care when the test date is. You know what I mean? This is just me trying to be helpful. Give you some ownership of what's going on and feel like you have a little bit of control. You know, sometimes that's nice. All right. And I'm going to do this actually. I'm going to put in the calendar the Chapter 1 test. I'm going to schedule it for that Thursday of next week. If we decide on the quiz day that you guys want to move it back till after Labor Day, that's fine. But I just want to put it in the calendar so I don't forget to update it later on. You guys will probably be more apt to remind me if it's on the calendar. But it doesn't mean it's written in stone by any means. Like, I'm happy to have a conversation and let you guys have a say in what's going on. Okie dokes.